Hello, welcome everybody. So today we are having a look at the topic setback distance. So it is a clearance distance provided on a circular curve to ensure that adequate side distance on the curve is available. Now what does this mean by this is whenever a vehicle is moving on a curve, this is the path that the vehicle is going to follow. And for that, the stopping side distance as we calculated earlier, this is the total stopping side distance that is available for the vehicle to stop the vehicle. If there is some building over here, there needs to be a fixed distance that needs to be ensured that the building is away from the road at some distance. This distance is known as setback distance. So that is what is said in the definition. It is the clearance distance provided on a circular curve to ensure adequate side distance on the curve, right? So it basically depends upon the following. The first one is side distance of the road. It depends upon the side distance available on the road, and side distance indirectly depends upon the speed of the vehicle, type of road, and position of the vehicle. So these are the things that it depends upon. Next, there could be different cases of setback distance. The first case would be when length of curve is greater than side distance. If length of curve is greater than side distance, the side distance is bound to stop in between the length of the curve. If it is not so, the length of curve is smaller than the side distance, that would be the second case that we'll have a look at in next part. So as visible from the diagram, setback distance here, it would be equal to CD minus CO. If we look at this total this total figure, and this distance minus this distance would be giving to the setback distance, right? So that is the value of setback distance. That is what we have written in the topic as well. This is CD minus CO. Since CD is equal to the radius of the curve and CD is also equal to R, CA is also equal to R, so M can be given as CD minus CO. Now CD is equal to R and CO is equal to R cos alpha by 2. Now what is alpha by 2? Alpha by 2 is the angle subtended by the curve on the center of the curve. Alpha is the total angle and alpha by 2 is the half of that angle, right? So for triangle ACO, CO is equal to R cos alpha. If we look at this triangle, if we look at this value is equal to R and this angle is alpha by 2. So this length automatically would be equal to R cos alpha by 2, right? So that is that. And next, M then can be written as R minus R cos alpha by 2, which can further be written as R1 minus cos alpha by 2. Now for the arc AB, since this is the arc, so the length of the arc can be given as R into alpha in radians. So that is what we have written here. AB is equal to R into alpha. Alpha is in radians, so we have multiplied by 180 by pi. So alpha can be calculated from the two values, that is side distance and R. Since we will not be knowing the value of alpha, side distance is available with us and the radius of curve we have already designed. Alpha can be calculated easily, right? Next, side distance is calculated along the center line of the road. That is correct. M is the setback distance measured from the center line of the road. These are the points to be noted. Next, when there are more than one lane, the side distance is measured along the inner lane and setback distance is to be measured from the center line of the road. What does this mean? Is that the side distance is measured for the innermost vehicle, the vehicle moving on the innermost lane of the road, and the setback distance, it is to be measured from the center line of the road. This is the point from where the setback distance is measured and the side distance is measured on this line, right? So for this particular case, let us have a look at the calculation of the setback distance. let D is the distance of center line of inner lane from center line of the road. So if we look at this road, this is the total width of the road, right? This is the center line of the road. This is the center line of the inner lane, and D is the distance of center line of inner lane from the center line of the road. That is what we have written. Let D is the distance of center line of inner lane from the center line of the road. CA is given as R minus D. For this, CA is R is measured from this point, so CA can be given as R minus D. CB is equal to R minus D as well. CB is measured as R minus D. OD is equal to M, which is equal to setback distance is measured from the center line of the road. So this value would be M. So M is automatically equal to CD minus OD. So D, that would be equal to W plus WE by 2 upon 2. So what we mean by this is, this total width would be W plus WE. If we halve this, we'll get this value, which is equal to W plus WE by 2. And if we also halve that, we'll get WE plus W upon 2 whole to be divided by 2. That is what we have written here. So D is the value which is equal to W plus WE upon 2 divided by 2. It automatically means that W plus WE upon 4 is equal to D. Right. Next, alpha by 2 is represented as side distance upon 2 multiplied by R minus D. Since CA is represented by, or any inner portion of the lane is represented by R minus D, alpha is automatically equal to side distance and R minus D, right? It is measured from this point. Next, alpha is equal to SD upon R minus D, and it is multiplied by 180 upon pi to get it converted into degrees, right? Next, M, it is equal to CD minus OC. CD is equal to R, OC is equal to R minus D cos alpha by 2, which is already calculated from this point. OD is equal to R minus R cos alpha by 2. So this total length is R. This length is R cos alpha by 2. Right? So OD is equal to R minus R cos alpha by 2. That is what we have written. R minus D cos alpha by 2. Next, M, it is equal to R multiplied by 1 minus cos alpha by 2, and in the summation we have D cos alpha by 2. So this is the value of M that we have to calculate whenever we are trying to calculate the setback distance when the length of curve is greater than side distance. Right? Then comes the another case when length of curve is less than side distance. For single lane road it is different, and for multi-lane road it is different. So first let's have a look at this diagram. In this diagram, the curve is starting from D to E, and the side distance that we have available and we have calculated is from A to B. So the length of curve is smaller than side distance. Since length of curve is smaller than side distance, this distance has to be calculated separately. For calculating this distance, we have to calculate FG as well as OG. OG has to be calculated from this diagram, and FG has to be calculated separately. So for this particular diagram, let's have a look. OF is equal to M, which is equal to setback distance. OF from this point to this point, it is equal to setback distance, which is equal to OG plus OF. OG and OF, this is the value. OG is also equal to HD. Since these are perpendicular, these are equal. This point, the side distance is starting. So this total line, let me have a, this is equal to S, which is equal to side distance of the road, and this would be representing length of the curve, right? Right. Next, we have to calculate OG, right? OG can be calculated from this triangle. If we draw this diagram again, let me draw this diagram in detail. This would be circular. This would be H, this would be D, and this would be A. This line would be alpha by 2. This angle will also be equal to alpha by 2, right? So for calculating HD, we can say that AD is equal to sine alpha by 2. How can we say that? This length AD is known to us. This would be equal to side distance minus length of curve divided by 2. AD plus EV would be equal to S minus LC. As we have given, S is the side distance, L is the length of curve, and this distance would be equal to side distance minus length of curve divided by 2. So that is the distance of S minus D. Sorry, AD. This would be S minus LC upon 2. So for HD we can say that HD is equal to S minus LC upon 2 multiplied by sine alpha by 2. That is what we have written in the below line. This we have written, right? And what else? GF would be equal to R minus R cos alpha by 2. For looking at this triangle CDG, we can say that CG is equal to R, which is equal to CG is, let me write it again. CD is equal to R. This can be written as R, right? So CD is equal to R. CG is equal to R cos alpha by 2, and CGF is equal to R minus R cos alpha by 2, right? That is what we have written here. So next is AD. AD is equal to SD minus LC by 2. I have already written that here. HD is equal to AD sine alpha by 2. That also we have written, right? Next is M, which is equal to, this is a formula that we have to remember, otherwise if you want to understand, you can understand as well. M is given as SD minus LC by 2 sine alpha by 2. That means this value plus R minus R cos alpha by 2, which is GF value. So if we sum GF as well as HD, we will get the value of M. If we sum the value of GF as well as HD, or we can say OG, let me write it here also. This is also equal to OG. So if we say that this is equal to OG and this is equal to GF, it would not be wrong. So OG summed by GF is the total value of setback distance. This is the formula for that. You have to remember this. Next is alpha by 2. Alpha by 2 can be calculated as LC divided by 2R. Alpha by 2 is LC, the length of curve divided by 2 multiplied by R. So that is what we have written. Alpha is equal to LC upon R, right? And alpha, this is the final formula for getting the value of alpha, right? This will have to remember. Next, for multi-lane roads, how it is calculated? This is a formula that is given and has to be remembered. R1 minus cos alpha by 2 plus D cos alpha by 2 SD minus LC sin alpha by 2. And alpha is calculated as LC upon 2, R minus D, 2 and 2 will be cancelled out, and we'll get alpha is equal to LC upon R minus D multiplied by 180 upon 5. So this is how it is all calculated. Next, two things needs to be taken care of, or it is given as special note. Setback distance from center line of inner lane would be given as M minus D, and setback distance from center line of outer lane, it would be equal to M plus D. These are the pet questions that you generally face in some state exams or IES or some 1 mark question. So that you'll have to remember, and this is a practice question that I have given. You'll have to calculate the setback distance for these roads, and you will reply to me with a comment below this video. I'll try to see how many people try to get the concept or solve the question properly. Otherwise, if you don't want to solve it, that is also okay. I'll solve it in the coming videos. If nobody gets the answer correct, I'll solve it in the next video, right? So let me explain the question as well. It says a two-lane highway has a horizontal curve of radius 200 meter. So that means that radius has been given, which is equal to radius is equal to 200 meters. Total length of the curve is 240 meter. The distance between the center line of highway and center line of inner lane is 1.95 meter. If the desired side distance is also given 340 meter, determine the setback distance required. So setback distance has to be calculated. Number of lanes has also to be seen, and we need to find the value for it. I need the value for m. These are given, and we need what is m. Right. So that is all from my side for this video. Next we'll have a look at curve resistance. For that, try to make sure that you watch this whole video. You like this video as well, you comment the answer of the question, you subscribe the channel as well. That would be really helpful for the channel. So thank you, have a good day, take care. Thank you.